All right, so we are looking at the second half of section 6.3, where we're looking at revolving around an axis other than the x or the y-axis. And in our textbook, they actually only gave us one example. That was example number 4, where you were revolving around a different vertical axis. They did not have an example of a different horizontal axis. So that's why we want to start with our challenge from last night, number 19, because that gives us the other example that we need for today. Okay, so for number 19 from last night, it said, use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves around the specified axis. And so for 19, it says, do y is equal to the square root of x minus 1. So y equals the square root of x minus 1. Y is equal to 0. So y equals 0, of course, is our x-axis. And x is equal to 5, so x equals 5 would just be a vertical line right here. So first off, I need to see what region that just bounded in. If I've got y is equal to the square root of x minus 1, we know that's our root function with a horizontal shift of a positive 1, right? So I know the square root looks like this. It normally starts at 0, so I've got a horizontal shift of positive 1. There it is. All right, so there's that graph, and they also had given me the x-axis, and they had given me y is equal to 5. So what got bounded in was this little region that we've got in blue. Now they tell me to revolve that around y is equal to 3. So remember that my height is always parallel to what I'm revolving around. So I'm going to cut a height that's going this way that is parallel to what I'm revolving around. So if I take that and I spin it, then you can see that creates our koozie. And of course I could come down here and cut another cross section and spin it, and that would make a koozie on the outside of it. And come down here or come up here and cut another cross section and spin it, and that would make another koozie on the inside of it. So it's that idea of those nested koozies that give us that total volume. So let's find the volume of one of them, and then we can sum it up. So if I'm going to find this volume, I'm going to need a height and a radius. So let's start with my height. My height is going to be right minus left. Now, if it's going to be right minus left, I need x values, right? So I'm going to go through and I'm going to say this was x is equal to 5. So I'm going to say 5 minus whatever this x value is over here. So my height is 5 minus whatever that x value is over there. That equation was y is equal to the square root of x minus 1. So if I need to know what it is in terms of x, I'll just solve it for x. So I'll square both sides and then add 1 to both sides, and so x would be y squared plus 1. So I can say, okay, 5 minus whatever that x value was, it was y squared plus 1. So 5 minus y squared minus 1 would give me 4 minus y squared. So that's where our height comes from. So one more time, our height is parallel to the axis that we're revolving around, so we need to do the right minus the left. That was this x value minus this x value. So we said this x value is 5. We need to figure out what this x is. So we just wrote it as 5 minus x. And then we came up here and solved that other equation for x so that we could slot it in and subtract. And that gave us our height. Now we need our radius. Our radius is going to be perpendicular to what we're revolving around. So our radius is going to go this way. So if I'm looking at that radius, the total distance between y equals 3 and y equals 0 would be 3, right? So this total length would be 3. I don't want that total length. I just want this little piece right here. So I'm going to have to subtract off this piece down here. Well, if I start at 0 and I come straight up, that's just a y value, right? So all I have to do is say I need this total length of 3 minus that straight up y value. So my radius is just going to be 3 minus y. Now everything automatically laid itself out in terms of y, so that leads me to remember that when I'm revolving around a horizontal axis by the method of 6.3, everything is in terms of y. And that would also lead me to pull the y values for this function. So this was 1, 0. Over here, if this is x equals 5, if I plug that into my equation, then I can say, okay, 5 minus 1 is 4, square root of 4 is 2. So that would give me the ordered pair 5, 2. So I'm going to pull the y values, and I'm going to integrate from 0 to 2. Now, remember for the test, I'm only interested in your setup, but I did go ahead and solve this one out just for practice of integration so that we don't lose that skill. All right, look at example 4. Example 4 says, find the volume of the solid obtained by rotating the region bounded by y is equal to x minus x squared, y is equal to 0, and x is equal to 2. All right, so first off, I have to graph y is equal to x minus x squared. That's just a parabola. So if I'm going to graph a parabola, it'd probably be helpful to have x-intercepts and vertex, right? All right, so let's start off with taking this parabola, and I really get 2 for 1 here, because if I'm trying to find the area under the curve in between y is equal to x minus x squared and y is equal to 0, I'm going to set those two equations equal to each other and solve to find the points of intersection, right? Well, when I set that function equal to 0, I'm also getting my x-intercepts, right? So I get 2 for 1, kind of nice. So we'll solve our little parabola down here, and we get solutions of 0 and 1. So I have an x-intercept here, and I have an x-intercept here. We know the vertex then is always halfway between the two x-intercepts, so I would know that my vertex would be at 1/2, and then I could plug 1/2 back into my equation and get 1/4, so that would be the vertex. Or I could do negative b over 2a to get the x value and plug in, find the y value, whatever you want to do. We also had a negative leading coefficient, so we know this parabola is going to open down. So that's how I could get that graph of y is equal to x minus x squared. Then we've got y equals 0. So this is the region that just got bounded in blue that we want to revolve, and they tell me to revolve it around x is equal to 2. So I'm going to come over here, and we have our vertical axis. Now, this would be one of those problems that if I had the option of using the method of my choice to solve, either the method of 6-2 or the method of 6-3, I do not want to have to solve this equation for x. It is so much simpler if I can work with it in the form that it is here. And again, that's the reason why we learned section 6-3. If I only had the method of 6-2, I would have to solve this for x to try and be put in this equation in terms of y instead. So it's just kind of nice to have options. Okay, so if we take that region and we revolve it around x is equal to 2, then I could cut a cross section. So here's my cross section that we spun, and you can see kind of the image of the koozie over here that is created. So again, I need to create an equation. I need the height and I need the radius. So let's start with our radius. You can see if we're starting right here and going out to that portion, this total length from 0 to 2 would be a length of 2. I'm not using that whole length. I'm only using this piece right here. So I'm going to have to say 2 and then subtract off whatever this little piece is over here. If I start at 0 and I go straight across horizontally, that's just an x value. So I could say my radius is going to be this whole length of 2 minus this straight over x value. That would leave me with just this piece right here, so my radius would be 2 minus x. All right, my height is parallel to what I revolve around, so my height is going to go up and down, so I'm going to do top minus bottom. So for my height, my top equation is the parabola, and my bottom equation is the x-axis, so it's 0. So that would just give me a height of x minus x squared. And again, it just laid itself out in terms of x without me having to memorize that, but we do know with method 6-3 that with the cylindrical shells that everything is going to be in terms of x. And so I can use my x values here of 0 and 1. And again, we are just looking for the setup. You do not have to solve it out on your homework or on the test. Okay, so here is our homework for tonight. I did give you one even problem, so I went ahead and gave you the answer for that one. Again, remember, you don't have to integrate them, but if you just want to check yourself and know that you're getting these right, you would have to throw the integral into your calculator, and so you'd want to know what answer you were trying to get to. So page 392 to 393, we're doing 7, 8, 13, 15, 19, 23, 35, challenge 25.